So hi everyone, this is going to be our presentation on our mixed membrane solution for the separation of CO2 from industrial effluent gases. So as we're all likely aware, CO2 emissions from burning fossil fuels are a major driver of climate change, especially in highly populated areas where CO2-rich industrial fumes could have significant harm to the local communities. So we wanted to find some type of way to limit the concentration of these drafting greenhouse gases on the daily lives of those who live near these types of plants. So generally, polymeric membranes such as synthesized polymers of intrinsic microporosity, or PIMs, can be used to separate the greenhouse gas contaminants from the effluent gases of industrial facilities. However, these lack long-term operational stability and have limited efficiency due to their trade-offs between selectivity and permeability. Thus, we chose to develop a mixed PIM1 polymer matrix integrated with porous carbon-based zinc composites to increase both the structural resistance to deformation as well as the transport capabilities. These zinc oxide-rich complexes act as absorption sites for the CO2 due to their lattice oxygen molecules, with their dispersed nanopores throughout the crystalline structure acting as a chemically attractive target for the CO2 in the feed. So this is just the process flow diagram for our system. When it comes to the heat exchanger pump and compressor, we're assuming that this hardware would be integrated into the effluent piping within the plant itself, so we're just defining our boundary explicitly by the compressed gas feed and the membrane.
As can be seen by the numbers, this membrane technology is quite promising. The calculated purity and recovery of carbon dioxide is quite high and is close to what has been seen experimentally. Additionally, the cost per metric ton of carbon dioxide is under the capture cost target for transformational post-combustion capture technology set forth by the United States Department of Energy. It is also between the range of carbon capture cost per metric ton seen in industrial processes producing pure or highly concentrated carbon dioxide streams. As a result, this membrane could be a potential competitor. However, this projected membrane area is still quite high, which leads us to our next topic. One advantage is that some of the numbers, such as cost per metric ton or recovery of carbon dioxide, found through pilot scale calculation and experiments, are low or high as wanted, respectively. Another advantage can be seen in the trade-off between selectivity and permeability. This relationship, called a Robson number bound, is not as strong as seen in traditional membranes. Thus, it is possible to have both high permeability and high selectivity. Regardless, one risk is that more research is needed to quantify the degradation rate, overall long-term stability, and the effect of impurities on the membrane. Additionally, given the high membrane surface area, there needs to be some research done on lowering the cost of production, as well as testing and improving scalability.
After finding the levelized cost of carbon dioxide produced using this integrated membrane, we decided to compare this value of $23 per ton of CO2 produced with other membrane technologies on the market. And we saw that for inorganic membrane, they have an average levelized cost of $75 per ton of CO2, while for facilitated transport and conventional polymers, they have an average cost of $50 per ton of CO2 produced. And from these cost values, we see that we're able to obtain more CO2 in the permeate stream at a very low cost because of the high selectivity and permeability we're able to obtain using this integrated membrane. So to go over our main points, we saw that using this integrated membrane has a lot of benefits because it enables us to obtain very high selectivity, high permeability, and high CO2 purity in the permeate stream. Also, we obtained the levelized cost of $23 per ton of CO2 produced, but this cost may vary based on the scale of our operation. Lastly, we think that more research needs to be done to further characterize other membranes that would have lower costs of CO2 produced and that can last for a very long time.